Okay, so LT3, we're going to solve rational functions. There's a couple of different ways we can do it. So first off, we want to find the lowest common denominator. And if looking at the denominators, what exists in one denominator has to be in the rest of them. So we have an x, so then I need an x over here and here as well. So x, and then there's an x minus 3, so I also need an x minus 3 in all of them. So the idea is to totally get rid of the denominator and cancel it out. So what we have to do is take the x times the x minus 3 and we're going to multiply that by everything in the original equation. The idea is to get rid of the denominator. So here again we multiply by x times x minus 3. And that's going to be 1 over x we're going to multiply by. And then we have x times x minus 3, and we're going to multiply x minus 1 over the x minus 3. Okay, so what happens when we do that is anything top and bottom will cancel, and again the idea is to completely get rid of the denominator, and that means we're going to be left with x times 2 plus, here we're going to cancel out the x, the numerator and the denominator that divides out. We have x minus 3 times what's left here is 1, equals, here we're going to cancel out the x minus 3 again, and we are left with x here times this x minus 1. And now we have an equation with no denominators, and that's the plan. So put 2x plus, we're going to distribute here, we get x minus 3 equals on this right side x squared minus x. I'm going to pull these over here, so I have x squared. The 2 and the x becomes 3x, and I'll move it to this side, so negative 1 minus 3 is negative 4x, and pull the 3 over, so I have plus 3. And from there, what I want to do is then factor it as a quadratic. So, two sets of parentheses, and to make x squared, it's going to be a 3 and a 1. I want to make a negative 4, so negative 1 and negative 3. I'm bringing them in the solve set equal to 0, so x minus 1 equals 0, and x minus 3 equals 0. And from there you'll know that it's x equals 1 and x equals 3. Now, one part we haven't done, so we know what the lowest common denominator is, but we didn't say what values x cannot be. So x cannot equal, looking at the denominators, it can equal 3 because if it's 3, I put 3 here, 3 minus 3 is 0, and we cannot divide by 0. Here we just have an x, so if I put 0 right there where x is, that would also cause a problem. So x cannot equal 3, and x cannot equal 0. Looking at our answers, we had 3 as an answer, so that's not our final, that's not part of our solution. So our final solution is 1. Now, the second way to do this, same problem, 2 over x minus 3 plus 1 over x equals x minus 1 over x minus 3. And if you just put parentheses for all denominators and anything in the numerator, that'll make things a little bit easier. So the other way is to look at it, how can we make all these denominators the same, how we did when we're adding and subtracting. So again, it's got to be lowest common denominator has to be x times x minus 3. We're looking to see what's missing. So this has got an x minus 3, but it doesn't have an x. I'm going to multiply top and bottom by x. Here, we're missing an x minus 3. I'm going to multiply top and bottom by x minus 3. And here, we're missing an x. So what's happened here is all the denominators are the same. And if all the denominators are the same, what you're left with is just the numerator, because this side is equal to this side and they both have the same denominator. So 2x plus x minus 3, and basically cancelling out all the denominators because they're all the same, equals x minus 1 times x. And then we get the same, put this together, we have 3x minus 3 equals x squared minus x. Pull this over, we get x squared minus 4x plus 3, and then it comes back to the same problem as before. Alright, one more. So we have the problem x over x plus 2 plus 7 over x minus 5 equals 14 over x squared minus 3x minus 10. So your lowest common denominator, well, can't do that yet until I get everything factored. That's the first step. Go ahead and factor it. X over x plus 7, 7 over x minus 5. There's nothing I can do there. I'll just put it in parentheses. Can you keep our brains right? We have 14 over, when we factor this, we have x and x. We need to make a 10, so 5 and 2 or 10 and 1. But I also have to make negative 3. So I have to make this a negative 5 and positive 2, because when I add those together, I get negative 3. And notice that I have an x plus 2, an x plus 2, and an x minus 5. So our lowest common denominator is x plus 2, x minus 5. And while we're here, values that x cannot be is negative 2. Because if I put negative 2 here, I get 0. X cannot be 5. If I put 5 here, I get 0. So there are two problems. We can do it how we did the second way in the last problem. Let's make them all the same. So we've got x minus 5, because we need an x plus 2 and an x minus 5, the lowest common denominator. So now this has the same denominator. Multiply this one by, squeeze this in here, x plus 2, x plus 2. And this has it, so there's nothing I have to do here. So now that x minus 5, x plus 2, x plus 2, x minus 5, x plus 2, x minus 5, I can ignore the denominators, and I can write it as x minus 5 times x plus, just the numerators, x plus 2 times 7, so this part here, notice that addition, this is multiplication, equals just 14. So we get x squared minus 5x plus 7x plus 14 equals 14. And here, for our like terms here, this is a negative 5, so we've got x squared plus 2x. These 14s cancel out, equals 0. And then I can factor out an x, and I'm left with an x plus 2, the greatest common factor. And then this part here gives me x equals negative 2. And then this part here is just, there's no numbers with it, so it's just x equals 0, or no numbers that we can see. And then going back to here, it cannot be negative 2 because that's a fake solution or extraneous solution. So final answer is just 0.